Okay, so today's topic is sequence and series. It covers two parts: arithmetic sequence and series. Second one, geometric sequence and series. What is the difference between arithmetic and geometry? See this sequence. First number is say 1, second is 3, third is 5, fourth is 7, and so on. So you can see that every next number is coming with a constant difference of 2. So what is the D? D stands for a common difference, which is next term, which is 3 minus previous term, which is 1. 5 minus 3, which is 2. 7 minus 5, which is 2. So difference should be constant, but when you count the difference should be always next term minus previous term. See one more sequence. Common difference cannot be always positive. It could be negative also. So I'm starting with the bigger number, say 9. Next number is 6, which is reduced down. Next number is 3, which is reduced down. Next number is 0, which is reduced down. So again, we will calculate the difference D, which is 6 minus 9, which is minus 3. 3 minus 6, which is again minus 3. 0 minus 3, which is again minus 3. So you can say that this is the arithmetic sequence. So what is the difference? Common difference means D always denoted by next term minus previous term. This formula is not given in a formula booklet, but you need to understand difference is always next term minus previous term. What are the notations we are using in arithmetic sequence? First term is always denoted by U1, or sometimes they denote by small a. Common difference, as we have seen, NT minus PT. NT stands for next term minus PT stands for previous term. Now here I know first term is 1, second term is 3, third term is 5, fourth term is 7. If I'll ask you to find out the 100th term, you don't need to write down all the terms up to 100. It is a time consuming process. So you use this formula, UN is equal to U1, which is your first term, plus n minus 1 times D. N is basically which number of term. If I'll say 100, your n should be 100. And D is a difference, which is in this case is 2, or in this case is minus 3. Use bracket properly. If I want to ask you to find out the sum of all 100 terms or all 50 terms or all 70 terms, again it is a time consuming process. So these are the formulas are given in a formula booklet. There are two formulas. First formula is specifically used when you know total number of terms, that is n, you know U1, you know n, and you know difference. So n over 2 bracket is very important, 2 times U1 plus bracket n minus 1 times D, and the main bracket is completed over here. Second formula is useful if you know total number of terms like 100, 50 or whatever that, bracket. If you know first term, if you know the last term, that means if you know the 50th term or 100th term, you know you have to substitute that over there. So second formula is a very short formula, but only in the case if you know first term and you know the last term, then you can find out directly the sum of that. This is arithmetic sequence. Let's move ahead on the geometric sequence. Geometric sequence, again I am taking the similar 1, 3, 9, 27. I can see the difference is not constant. Here the difference is 2, here the difference is 6, here the difference is bigger than that. So what is the another possibility? That means the ratio has to be constant. Look at the ratio. 3 divided by 1 is 3. 9 divided by 3 is still 3. 27 divided by 9 is still 3. So you can see the ratio is constant, which is always next term over previous term, which is also denoted by common ratio. I am taking another sequence. Here I am starting with the bigger number 8, 4, 2, 1. So you can see 4 divided by 8, 1 by 2 or 0.5. 2 divided by 4, 1 by 2 or 0.5. 1 divided by 2, 1 by 2 or 0.5. So a ratio can be more than 1 or less than 1. Depending upon more than 1 and less than 1, there is one more sequence called as the infinite. Again, let's focus on what are the notations they are using. as like in an arithmetic progression, first term is denoted by u1. So here geometric sequence, first term is also denoted by u1. In geometric sequence, ratio is denoted by next term over previous term. If I want to find out any term in this sequence, say let's say 100 term I want to find out, then I will use u1 times r raised to n minus 1. Now understand, this raised to n minus 4 is only applicable for r, not u1 times r. It is only for r raised to n minus 1. And there is a sum formula, u1 times 1 minus r raised to n. Look at this, n is only for r, not bracket raised to. u1 times r 1 minus r raised to n, bracket complete, over 1 minus r. As I said you, it depends upon r, your one more sequence exists, that is called as sum to infinity. Sum to infinity always exists if your r, that is a common ratio, is between 1 and minus 1. So sum to infinity is basically u1 over 1 minus r. Because if you'll see, if your r is between minus 1 and plus 1, if you'll take n, that value raised to power say 10, 20, 30, this r raised to n approaches 0. 1 minus 0 is 1. 1 times u1 is u1. So that is why this is u1 and divided by 1 minus r. One more thing, whether it's an arithmetic sequence or geometric sequence, you will decide only with the help of 3 consecutive terms. Not first 3 consecutive terms, but any 3 consecutive terms. So if I'll give you only 1 and 3, you cannot decide whether it's a arithmetic or geometric. But when I give another number, third consecutive number, that is 9, then you can say that this is a geometric sequence. Thank you.